to my channel, the Physics Nexus, and today we will discuss about the most important topic, which is gravitation. Sorry for my handwriting. Yeah, wait a second. Yes, gravitation, force of gravitation, basically. So the formula for the force of gravitation is like force, which will mainly G, but it is too small. Yes, force equals to gravitation force or universal gravitation constant into the mass of the first object into mass of the second object divided by radius squared, which was as stated by Sir Isaac Newton in the year 1665 by discovering his gravitation force. So today we'll try to discuss and solve about the basic problem among this formula, and we'll try to solve that. So in our first question it is given that find the gravitation force between two masses of 5 kg and 10 kg placed 2 meter apart. So if I just draw like this one is the 10 kg one and this one is 5 kg one, which are placed between 2 meters. Sorry. Yeah, which are placed between 2 meter. The distance between them is 2 meter. So according to the force of gravitation, we get that the gravitation constant, which is about 6.674. Wait a second. Sorry, there was a connectivity problem, so now I can resume. So now if we take two block, this one 10 kg and this one 5 kg, so according to the force of gravitation, we get that 6.674, which is the universal constant of gravitation with 10 to the power minus 11 into the mass of this, the biggest one like 10 kg, and into the mass of the 5 kg, which will be like 10 into 5 divided by the square of the radius between them, means the distance, so it will be 2 square. So approximately the force of gravitation should be, yeah, calculated, so it will be 8 point, sorry, 3 4 into 10 to the power minus 10 newtons. So this would be the answer of this first question. Now we move on to the second question. Yeah, it is given here that if the distance between two 1 kg or 1 kilo masses is doubled, how does the force change? So according to the force of the gravitation, we know that force is inversely proportional to the distances among them. The distances among them or the masses doubled. So here, as the distance between two 1 kilo masses is double, so we get 2, and if their masses is double, Hence, their force changes by 2 is to 2, which is equals to simply 4 times. So this will be the answer of this second question. I hope that you can understand my handwriting, and I'm very sorry for that. So I'm repeating again that if the distances between two 1 kilo masses is double, and now as the force of gravitation is inversely proportional to the squaring of the distances, which is already given in the formula, that force of gravitation equal to gravitational into mass of the first object into mass of the second object divided by radius square. So the answer will be changed as 2 into 2 times, which will be 4 times. And move on to now, it is given that two equal masses of 20 kg are placed 5 meter apart. So, if we take 20 kilo equal masses, which will be like here, the gravitational force will be 6.6 and 4 into 10 minus 11, which is the universal gravitation constant, into the mass of the first object, which is 20, and the mass of the second object, which is 20, which will directly 20 square, which will be 400. And if the distance is 5 meter, so the total distance for this formula required to calculate will be 5 meter square, or just directly 5 square. So answer will be directly get that 6.674 into 10 to the power minus 11 into 20 square, which is 400, divided by 25. So the approximate answer of this uh, question will be 1.079 into 10 to the power minus 8. Wait, let me check a bit. Wait a second, it was close, but the real answer, or the true answer, is 1.07 into 10 to the power minus 9. A slight mistake. So the answer will be 1.07 into 10 to the power minus 9 will be the gravitational force between these two masses. Now we move on to the second, or no, I think fourth question. Yeah. So now it states that find the force between the Earth, which has the mass of 5.97 into 10 to the power 24, and the Moon, which is 7.35 into 10 to the power 22. If the distance between them is 3.84 into 10 to the power 8 meter. So it might look you like complex, but it's not so much that complex. The answer will be, according to the force of gravitation, it will be like 6 as the gravitational constant. Sorry, 6 into 6, 7, it is a point. Oh, yeah. 1674 into 10 to the power minus 11 gravitation constant into the mass of the earth, which is 5.9, yeah, 97 into 10 to the power 24 into 7.35 into 10 to the power 22 divided by the 3.84 into 10 to the power 8 in whole square. So the approximate answer will be 1.1.98 into 10 to the power 20 Newton. So this would be the answer of this question. And so I think that you have understood that how to do some force of gravitational problems among the heavenly bodies like Earth and the Moon. And so for today, I will stop till here only. And if you like this video, so please like and subscribe my channel, and I will provide with many more interesting topics later. So for here, goodbye, stay safe and stable.